Centrifugal pumps have long been used in the fire service due to their efficiency and capability of operating at a wide range of volumes and pressures. They operate on the principle of centrifugal force, which is water's tendency to flow outward from the center of rotation with a revolving body and take advantage of incoming pressures. Understanding how the pump is designed and operates is fundamental to efficient operations. The first step of operating the fire pump is transferring the transmission through the pneumatic shift. This is where we alternate between driving mode and pump mode. It is a pneumatic shift that operates by an electric controller. The collar transitions across the drive shaft, which engages with either the rear drive shaft of the drive axle or the pump drive's sprocket. When transitioning to pump mode, the collar will disengage with the rear shaft and shift forward to engage the hub of the pump drive sprocket. This in turn disengages the apparatus's ability to drive and transfers the power to the pump itself. Next, to the water intakes. There is a 5-inch intake and a 3-inch intake, also referred to as a pony suction, located on both sides of the pump. There is also an intake valve at the top of the pump located near the midline of the pump that allows water to flow from the tank to the pump. There are no valves within the pump itself from the point of intake through the discharge valve, and because of this, water can move freely throughout the pump when the impellers are not in motion. As the water flow enters the intake, it is channeled down the parallel piping to both sides of the pump. Water then enters the impeller shaft assembly through the eye of the impeller. As the impeller spins, it accelerates the movement of water between the vanes and discharges water outward into a collection area known as the volute. As the pressure within the pump increases, the water is displaced into the header where piping and valves deliver water to the discharges. So why isn't there water on the intake side of the pump pressurized when the pump is engaged? If you look at the design of the pump, you will see that there are technically two sides of the pump, a low pressure side and a high pressure side. Similar to the way a fan operates, the water on the intake side of the pump flows at a lower pressure until it is drawn into the impeller when in motion. Since these impellers only pressurized water in one direction, the pressurized water is incapable of flowing backward to the intakes, which would ultimately push water in the wrong direction and overpower the water supply. One other part of the impellers that warrants our attention is the impeller shaft and, more importantly, the packing used to seal the impeller shaft. The impeller shaft is a narrow metal rod that runs through the center of the impeller and allows the drive shaft from the engine to rotate the impellers. On both ends of the shaft is the pump packing. These braided graphite rings help seal the pump and maintain its efficiency. They are also cooled through cooling lines that run from the first impeller. These cooling lines are designed to leak a small amount of water. However, if the water in the pump reaches high temperatures, it will fail to keep the packing cool, leading to damage to the packing and decreased efficiency of the pump. This is what it means when we talk about the pump packing wearing out, and this is where many of the leaks within our pump occur. Once the water leaves the volute into the discharge manifold, it is then piped through several waterways to the pump discharges.